Okay, let's unpack this. You've probably run into open source AI models before. Maybe names like Granite Llama or Mistral ring a bell.
Yeah, or maybe you've seen that huge list, like over 1 million models, on places like Hugging Face.
Exactly. And these open models, well, they're popping up everywhere. They offer a ton of potential, but they also bring some new kinds of complexity, right?
Mm,
Especially compared to the open source software we're used to.
definitely different.
And you shared some really interesting material with us for this deep dive, which gave us a great place to start.
Hmm.
So today, we're going to take a closer look at open source AI. What does openness actually mean in this context?
And what are the implications, for transparency, how we use them, how we understand them?
Yeah, it definitely builds on what we know about open source software, but adds these extra layers, especially around the data, the training data, and all the specific bits that make an AI model tick.
The model components themselves, yeah.
So our mission here is basically to pull out the key insights from your sources, help you get a handle on the power, but also the, let's say, the challenges of open source AI.
Sounds good. Let's get into it.
Okay, so fundamentally, open source AI means AI systems that are, well, freely accessible.
Right. The sources stress that users should be able to study them, change them, modify them, and share the components, all under specific open source licenses.
And components here isn't just the code, like in traditional software.
No, it's more. It's the source code, yes, but also the model architectures, the kind of blueprint, the parameters, and really importantly, the weights.
Weights, okay.
And sometimes, and this is a really key point the material brought up, it might even include detailed info about the training data used to build the model in the first place.
The material you shared had a pretty neat analogy for
Oh,
this,
yeah.
like sharing a recipe for your favorite cake. Not just giving someone the finished cake, but the whole recipe.
The ingredients list, the exact measurements, those are kind of like the parameters,
Oh,
maybe.
yeah. And the specific instructions, like the architecture and code, and the weights. The source compare them to the really specific techniques.
Ah, like how exactly you fold the flour, or the precise oven temperature, the learned skill part that makes it turn out just right.
Exactly. And sharing all of that means others can truly understand how it works and maybe even improve on it.
That makes sense. And having that kind of access gives users some core freedoms.
Like what specifically?
Well, you can take a model, you can fine tune it, that's training it a bit more on your own specific data to adapt it,
Okay.
customize it for what you need it to do, and crucially, you can run it on your own computers, your own hardware.
It sounds like a big deal.
Huh.
Why is running it yourself so important?
Well, it can mean huge cost savings compared to paying for cloud API access all the time, and it gives you much more control over the system.
Right, control and cost. That ability to run and adapt things locally seems massive.
It really is. And the source material had this fantastic example of the open ecosystem working. It talked about engineers in Asia developing a model and a data set.
Okay, starting point in Asia.
Right. Then maybe a team in California took that work, built on it, perhaps distilled it down or adapted it somehow.
And then,
Then a nonprofit over in Texas used that adapted version, tailoring it specifically to help them write grants for certain kinds of projects.
wow, okay, so Asia to California to Texas.
Exactly. It just shows how openness lets people collaborate across the globe. A base model from one place gets refined, then applied to solve a specific real problem somewhere else entirely.
That really highlights how different teams can build on each other's work using these shared resources,
Hmm.
creating solutions in totally different areas,
It really brings that collaborative spirit of open source software into the AI domain.
for sure. Now, the material you sent mentioned that figuring out what really qualifies as open source for AI is still being worked out.
Yeah, organizations like the Open Source Initiative and the Linux Foundation's AI and Data Foundation, they're actively trying to pin down clear definitions and criteria.
So it's not totally settled yet.
Not entirely, but the material highlighted 3 components they see as sort of the most important ones for an AI system to be considered truly open.
Okay, let's break those down. What's the first one?
Transparency.
Transparency. What does that mean for AI?
So the core source code needs to be accessible, obviously, and under a standard open source license like MIT or Apache, things people recognize.
Standard stuff so far.
But the sources emphasized it goes further with AI. It should also include transparency about the methods used to build and train the model.
How it was made, not just what it's made of.
Exactly. And sometimes details about how the training data itself was put together or processed. It's about seeing the whole process, ideally.
Okay, so transparency covers the code, the methods, maybe the data origins.
Mhm.
Got it. What's number 2?
Freedom.
Freedom, like in regular open source.
Pretty much. Users should have the freedom to use the system, study how it works, modify it, and share it, or their modifications, without unreasonable restrictions.
And for AI, what enables that freedom technically?
Your sources really stress that access to the model weights is critical here. Remember the learned techniques from the recipe? The weights are like the model's core knowledge learned during training.
Ah,
Having those ways is what lets users actually make meaningful changes, fine-tune the model for new things effectively, and even contribute improvements back or build completely new models based on it.
so no weights, no real freedom to modify. Makes sense. What's the third key component?
Data openness. Now, this one's a bit tricky. It doesn't always mean you get the actual raw data,
Right.
but it means having comprehensive details about the training data is seen as crucial. Information about its scope, what kind of data is in there, how is it labeled or curated, what processing steps were applied.
Why are those details so important, even if you don't get the data itself?
Because that data fundamentally shaped the model. Knowing those details helps you understand what the model learned from.
Ah, so you can guess its strengths and weaknesses.
Exactly. You can better predict how it might behave, spot potential biases or blind spots, and judge if it's even appropriate for what you want to use it for. Without that context about the data, the model is much more of a black box.
Even if the code and weights are open.
Right.
Okay, so it's like having the recipe and knowing where the ingredients came from and how they were prepped, vital for knowing what you're actually cooking with.
That's a good way to put it.
So all this potential, this freedom, it sounds amazing.
Yeah.
But the sources were also pretty clear that getting there isn't easy. There are some big challenges.
That's very true. A major one is just pinning down what model openness really means in practice day to day.
What kind of problems come up?
Well, like the sources pointed out, sometimes creators might only share the model weights, but maybe not the full code used for training or the architecture details you'd need to really modify it deeply.
So incomplete information.
Or other models might only be available through a cloud API. You can use it, send data to it, get results back.
But you can't download it and run it yourself.
Exactly. You can't tinker with it locally. These situations don't really meet that full open definition we talked about, often because of tricky licensing issues around different parts, or especially around the data.
Ah, so you might get only part of the recipe, or you're only allowed to use it in their specific kitchen. You can't take it home.
Kind of like that, yeah.
What other challenges did the sources highlight?
A really big one is data disclosure. We just talked about data openness having details about the data being a goal.
Right.
But many creators of these big, powerful models are often, well, hesitant or maybe even unable to release the actual training data itself, or sometimes even comprehensive details about it.
And why is that? What reasons did the sources give?
A few things. Legal concerns are the big one. Where did the data come from? Does it have PII? Is the licensing clear? Ethical concerns, too, depending on what's in the data. And sometimes, honestly, the data set itself, or how it was curated and cleaned, is considered the creator's secret sauce.
Their competitive advantage.
Exactly. Something they're just not willing to share openly because it gives them an edge.
That makes total sense from a business angle, but it really clashes with that transparency goal and understanding potential bias if you don't know the data.
It absolutely does. It limits that deeper understanding. And there's another very practical hurdle, too. Compute power.
Ah, the sheer cost and resources needed.
Yeah. Training these huge state-of-the-art models takes an incredible amount of computation. You need access to lots of powerful GPUs, specialized hardware.
Which isn't cheap or easy to get.
Right. So that remains a pretty significant barrier for smaller companies, academics, or individual developers who might want to fully participate by training models from scratch or doing really deep research. It limits who can build at the cutting edge.
Okay, so defining openness, data disclosure issues, compute barriers, those are serious hurdles. But even with all that, the materials still really emphasize the benefits open source AI offers right now.
Oh, absolutely. The benefits are still huge. For individual developers or researchers, being able to just download a powerful model, run it on your own laptop or server, experiment with it all for free, that's massive for learning and innovation.
Opens a lot of doors.
And for organizations, it gives them flexibility. They can choose the model that best fits their specific problem. They aren't locked into one cloud provider's AI necessarily. They can deploy and scale these models using tools they might already use, like Linux or Kubernetes platform.
More choice, more control, potentially lower costs.
Exactly.
So given this mix, the great potential but also these real-world complexities, What practical advice did the sources offer if you're thinking about using an open source AI model?
They suggested a few key things. First, look for resources that can help you evaluate how open a model actually is. Like the Linux Foundation has a model openness framework with criteria you can check against.
Okay, so try to assess the level of openness first.
Yeah. Second, document everything. Use something like an AI bill of materials, basically, a record of which model you're using, what version, how you've configured or deployed it. Just good practice.
Keep track of what you're using.
And third, and this is critical, validate it yourself. Don't just assume the model works perfectly out of the box for your specific task. Test its performance, its accuracy, look for fairness issues on your own data before you rely on it for anything important.
Test, test, test. Solid advice. So digging into the sources, it seems the overall goal, the big picture aim of open source AI is really about fostering collaboration
Increasing transparency.
and ultimately building trust in these AI models that are becoming, so important in so many areas.
Yeah, it's pushing towards a future where we can not only use powerful AI, but we can actually understand how it works, check its foundations, and maybe even help make it better.
So wrapping up this deep dive then, we've seen the huge promise of open source AI, that accessibility, the freedom it offers to modify and improve models, the potential for amazing collaboration.
But we've also hit on the tricky parts. Defining what open really means for AI models versus traditional software. The big challenge of data transparency needing details about data that often aren't shared for various reasons.
And that practical barrier of needing serious computing power for foundational work.
Right.
And understanding these nuances, this gap between the ideal and the reality, is really important for you as you navigate this space, as you maybe start using these models yourself. It definitely makes you think twice about what open signifies when applied to AI.
It absolutely does.
Which leaves us with maybe a final thought to chew on. Given these challenges, the data disclosure issues, the compute requirements, the tension between open ideals and commercial realities, how does our definition, and maybe more importantly, the practice of openness in AI, how does that need to keep evolving?
Yeah, how do we evolve it to actually achieve that goal of widespread understanding, fairness, and genuine trust in the AI systems we're starting to rely on?
Something to think about as this field continued to develop so quickly.